right? I'm tired, but I can't resist this. I wanted to at least give Rvest a chance before I go on with my day. So here's Rvest example, but I want to pull down some data like this, data from wrestling.data.com. I want to see if I can pull out this information. So I took the URL. That's going to be my example URL. Now I should also point out that we are using somebody else's website. So be sure to check legal disclosure and privacy policy and anything like that if anything you make from this turns out to be public, like, for example, this video. So this video is more emphasizing the Rvest, but I would really like to thank, if nothing else, the human inclination to make hobbyist websites. This is fantastic. This is what the internet's supposed to be like. All right, so let's see what we got in RStudio so far. So I put in the example. I told R to read the HTML of the example. And now I got this by running this code example. I'm going to pipe into HTML_nodes. I'm going to look for a table. So this is literally like the 5th time I've used anything in Rvest. Literally right here, read HTML for the first time. I looked at the node, I looked at the doc, and I got these, right? A pointer. Okay, so it's pointing towards something in memory somewhere. I don't know how, but it's working. And then HTML node tables. Okay, so here is something. Here is something we can work with. So what I want out of this is going to be a specific table. I want the results, and this website was made by someone in German. There is a German version of it. So some of the stuff in the URL, Befehl equals shows. Befehl, it looks like a German word to me. When we look for the results, it's going to say Feld equals something, something in German. So some of it looks like made up stuff, but human language is made up. All right, so we want to get something out of here. Let's see, guitar on a pole match. That sounds incredibly scary. What have we got? Cookie OK action. That's definitely not the one we want. We got all this stuff about cell padding. We got title, wrestling, wrestler, win-loss, title, when did. We can find some of that stuff on here. When did, no. Wrestler profiles, search for wrestler. What's new? Maybe that's what we're looking at here. Line, center, cell spacing. We could dig into the HTML a little bit to kind of narrow down our possibilities. Your opinion on the show. Your rating. God, this is pretty neat. We got ratings. I guess that must mean how many people they estimate watched it. We got venue. We could tie this data to locations. That's really cool. We've got links to players, to wrestlers, so we can dig up data about how wrestlers are connected to each other and how their decisions affect outcomes over time. The question is, where is this data showing up in Rvest? So 2021, right? That's the right thing. Well, let's see what we can figure out from here. HTML text as numeric. Okay, so here they're looking at IMDb data, and I guess wherever it showed up with a strong span that looked like a rating. Title cast. Okay, so let's maybe look for some of these anchors. Let's use an inspect element here. This will let us poke around a little bit more directly than just looking at the HTML code. So, card, where is this showing up? It's not really what I want. I want results. We're in the body, we're in the center. We're in this table. This website is just tables on tables on tables. Body, particular rows. Okay, we want this table. Okay, we're getting closer. This table. Width is 98. That's telling us something. Width 98. Average age of wrestlers, 37.3 years old. Okay. It's not that, it's this. This is definitely what we want. So within this, table row, table style width 100. Here we go. All right. So TR title equals match 1. Average age of wrestlers. Okay, cool. So we found what we're after. And that was, whoops, what did I do here? Oh, yeah, that was just me fixing some stuff in that other data set. All right, so basically what I'm after is, I think, either this or this. I think it's 12. Let's see what happens when I do that. No. I think there's something in Magritte that'll let me grab that 12th element. Let's take a quick look there. Installation, basic piping. This is one of my favorite names for a package, by the way. Magritte. Cecine Pau and Pipe. Magritte is, of course, my favorite of the Belgian abstractionists. I don't even remember if I'm using that term right. It's been a million years since I spent any time thinking about not abstract art, surrealists. It's my favorite Belgian surrealist. Piping alternatives, yada, yada, yada. I'm sure there's some way to do the thing that I want it to do. All right, I'm going to do what I know works. So I want the 12th item here. So let's just call this tables. And then I'm going to say table is the 12th item out of tables. Let's make sure this makes sense. So tables, we got a list of 24. Table, I've got item number 1. Let's see what I can get out of table. Oh, not super useful. Not super useful yet. Attributes as numeric. There's got to be a way to extract what I want out of this. So this is the overview. Select parts of a document, such as yada, yada, yada. Extract components, HTML text, HTML attributes, HTML table. Here we go. Let's just pipe it straight into HTML table. Inconsistent number of columns. So let's say fill equals true. All right, this isn't what we wanted. Oh man, this is the outer table. So the tricky thing here might be getting the table inside the table. All right, so here are the tables we're looking at. XML node set. So let's just say for T in tables, we're going to do some stuff. What are we going to do? We are going to take T, we're going to pipe it through HTML underscore table with fill equals false. I'm going to leave that. I'm going to leave all the defaults. Let's just see what happens. All right, let's try it again. Fill equals true. Right. And we'll print. All right, so hey, that spit out a bunch of stuff. Let's see if any of it's good. It just dumped everything out here. But this last bit is really the stuff that I want. Guitar and a poll. So hey, let's make it X tables 24. And then we'll go table pipe to HTML underscore table. Let's see what we get. Okay, this one didn't have inconsistent columns. That's good. I think that that's a result of somebody's HTML decision. And let's see what happens when we print this. Cool, cool, cool. All right. X1 is just... Okay, so here's what X1 is. So of those 24 tables we pulled out of this website, there's a bunch of tables. You can see here's a table inside of a table inside of a table next to another table, and those tables are all inside of a bigger table. So when we looked too far up the list, we were getting this table that included tables inside of it. So it had weird numbers of columns in weird places. But the table we're concerned with is this table here that goes from 1 down to information about the match times of the event. So that has this column, 1, 2, 3, all the way up to 9, and then these 2 values, and then these 9 values, and then nothing. All right, so we go down to 10, and then we say this stuff, and then over here we've got these outputs, and then we just have, looks like we've got a repetition of that stuff. So let's call this T for temporary. So there's T. If you look at T, it looked like that was a list. There's T1, T2, nothing in T2. All right, so let's go T, look at square brackets. We'll look at the first row. Okay, we don't have 2 dimensions. What is T? T is a list. Well, let's look at the structure of T. List, where we have a data frame. So T1, we ask what that is. It's going to tell us that's a data frame. So what we really want is item 1 from this. Oh, here's why I'm printing that. Let's do that. Is T, is it still the same? I guess it's still the same. All right, so we're going to do this in a 2-step process. We're going to say T gets itself item 1. There we go. Now we've got T in table format, 11 observations of 2 variables. And really, variable 1, we don't really even care about. So let's look at T, all the rows, the second column. We've got average age of wrestlers. We've got information about the match times. This is the information we want from this page. So here's our basic procedure that we've got that hopefully will work for a whole bunch of web pages. We get the URL, we say read HTML. We take the tables from that HTML, right? So we can actually even skip this. We could run this through HTML nodes, nodes with a D, look for table, and then we'll take the last table. So we could say, well, let's go ahead and run this. So example, sorry. Let's call this URL. I'm using a variable twice in two different ways, which is a bad practice. All right, we got a URL. Our example is we read in that URL and we pipe it into HTML nodes. And now example is this list of 24. So let's say what we really want is our table is going to be out of example. So we'd use two sets of square brackets to look for an item in a list. So we could look for the 24th item, but just to be safe, I'm going to say, what is the length of example? Let me verify that that works. Length of example is 24. So if I look at example for the item that is the same as the length of example, this will give me the last item. So this gives me that last table. So this is the table I want. So I don't actually need this stuff. I wonder what would happen if I were to take this before I even said, let me get the last one. No, I'm not going to do that yet, because when we did HTML table on the whole thing, it was giving us problems. So we're just going to deal with it as here's a table. We've taken the table we want, and then as a data frame, that table is going to be table piped through HTML underscore table. And then we want out of that the first item, and then we're going to want the second column. Let's just see what we've got. There's df, and df is a list of 1. Now I'm going to use parentheses to just immediately go to item 1. So what this does is it takes this whole pipe and it says we're going to take everything that we evaluate inside those parentheses I've just highlighted. That's going to be some result. And then we're going to assume that that's a list and look for the first item in the list that hopefully is the result we get from this. Let's see if it worked. Perfect. df is now this data frame. And again, that first item in the data frame doesn't matter. So let's add a little bit more complexity here. This is making the code this is making the code less readable. So let's put it onto another step. What we really want, this is kind of the raw data. We're going to have to do some more stuff to really deal with this. We're going to take out of df all the rows in the second column. So now our raw data, and that is a pun in this case, and that's important, is now we've got basically just a vector. It's one column, but we've got, no, it's just a vector. It's a vector of strings. Each string represents some nugget of information about this match. So from here, we're going to have some more processing. But what have we got? We've got from something that you and I can read as a human being, but we can't deal with systematically on the scale of many, many different matches that we might want to roll together. We've taken this and we could, in principle, and hopefully will soon, apply this to all of these links and get a similar vector of basic data from all of those links. Now, the data is still a little bit trapped, right? So we need to extract, say, guitar on a pole match from Jeff Hardy defeated Elias. So we're going to have to, say, look for things like how long do things go on, right? We'll make that a field. We want to look for defeated. That's going to help us to identify wrestlers who are in this. We're going to look for by. So when we see by, that's going to tell us, did they win by submission or did they win by referee stoppage? So there's going to be some puzzles to solve here. But the good news is when we solve these puzzles, we're hopefully going to be able to look at this at a large scale. Now, like I said, I'm tired, but I got sucked into this. I can't look away, but I'm going to now. So let me just walk through what we've got here and get rid of that. This is really just a few lines of code encapsulating all we need to get most of the way there. Now, of course, most of the way there is not most of the way there. The first 90% of the time takes 10% of the time. But we get a URL. We read that URL with Rvest's function. We also use Rvest to extract the tables. We take the last table, and then from that table, we extract it. We extract the HTML into an R table format, which for some reason gives us a list. There might be a nicer way to deal with this, but this is the way that I'm dealing with it, given that I've seen this package for all of 25 minutes. We extracted the data from the HTML table, right? Remember that table looks like this, right? It's just HTML code. We extract that into a data frame. We take that first item, and that gives us kind of a mess, but we only need the second part of that mess. There is that second part. This is what we've gotten out of Rvest, and we didn't have to even hit Control F once. This is really nice. I was looking at this problem because I want to get better at web scraping. There's a lot of cool data on the web. This is a nice little motivation. And I was looking through the HTML code. I was doing regular expressions, which are fun and intellectually satisfying. But wow, this is just so much more efficient in terms of getting data out of this web page. So given that, there actually should be a way to look at a page like this, extract the tables from there. So with this is still even only a subset of this. We've got many pages, but in any case, there's some way we can find to dig through more of this, get a whole bunch of URLs and then loop over them, tack on something like saying that this is show number 492021, just so that we can keep this data distinct from the data that we're going to pull from, say, this one. And there's other data that we can pull out of this that we ignored, right? But we can pull that data out of the web page, apply a little bit of structure to it, and we can build basically our own database out of this website. And with a little bit more effort, be able to do some cool stuff. Now, I'm gonna stop. I'm gonna stop here with just one more comment, which is why I'm so excited about this. We've gotten not all the way there, but we've gotten the basic essence out of an HTML page in a way where we just needed to put the URL into R. And with 4 lines of code, we got basically what we want. You do a few more lines and you'll get a little bit more data, and then you'll have to do a little bit of stuff, like I said, to separate out the components of this. But once you figure out how to do that, then you can do it many times over, and you can sort of leverage your ability. So if I was just interested in this one match, I would just take a piece of paper and copy down what's here. But I'm not interested in this one match. I'm interested in the 6,000 matches that users of this website think are better. So given that, being able to pull the structure out and have the computer do the hard work is worth being excited about.